Hi, this is Swati. Today we are going to see the first chapter of the 9th standard, that is matter in our surrounding. In this lesson, we are going to learn what is meant by matter, classification of matter, properties of different states of matter, that is properties of solid, properties of liquids and properties of gases. After that, we learn what is meant by melting point, what is meant by boiling point, and so many things we are going to learn in this lesson. But in our surrounding, there are so many living things, non-living things, but those all are known as matter. But exactly what is meant by matter? Now see, if we want to define the matter, matter is anything which occupies the space and has mass. The meaning of that is matter are those substances which is having their specific mass. If we want to weigh that substance, it is having their mass, and to keep that substance, it requires some space to keep those substances. That's why the definition of matter is that matter is anything which occupies the space and has mass. If we want to keep that substance, it occupies the space. For example, if in one room we want to place 1000 people, is it possible to keep 1000 people in a one room? No, because each person requires some space. Each person occupies some space. That's why we are saying the matter is anything which occupies the space and has mass. Means in this universe, everything which is having their own mass and which occupy the space are known as what? Matter. Next we are the classic matter. Next we are early Indian philosophers classified in the form of 5 basic elements as air, earth, fire, sky and water, called Panchatattva. But nowadays, Greek philosophers also arrived at similar classification on the basis of physical properties and chemical properties. Matter is divided into many types. On the basis of physical properties, matter is divided into solid, liquid and gases. And on the basis of chemical composition, that matter is divided into homogeneous mixture and heterogeneous mixture. Now what are the meaning of this each term and their properties? We'll see one by one. First we'll see the physical state of matter. Now we know that there are mainly matter is divided into 3 states, that is solid, liquid and gases. We observed many things in our surrounding in these 3 forms, that is solid, liquid and gas. According to chemical composition, matter is divided into heterogeneous mixture and homogeneous mixture. Now, what are the properties of this solid, liquid and gas, as well as what is meant by heterogeneous mixture and homogeneous mixture? We'll see one by one. Now, what is solid, liquid, gas, and what is heterogeneous mixture and homogeneous mixture, and what are their properties? We'll see one by one. Now, before to understand the properties of that all 3 states and homogeneous mixture and heterogeneous mixture, we'll see what is the physical nature of matter. Means what are the properties of matter first we'll understand, and after that we'll see the properties of solid, liquid and gas. Matter is made up of particles. Now if we are taking example of anything which is present in our surrounding, even a small chalk we can take, that is made up of many particles. And the particles of matter are very tiny. If we see, the particle of each and everything is very small, made up of many small particles. Matter is made up of many small, that is tiny particles. And the particles of matter have space between them. Matter is made up of many particles. The space is present in between all these particles. The property is in each and every matter, particles of those matter are continuously moving. We feel that these particles are stable, but actually the particles of matter are continuously moving. And next property of that is the particle of the matter attract each other. These all are the properties of the matter, or we are saying physical nature of the matter. Now see, how we understand, or if an activity is given in your textbook that matter is made up of particles. By doing this activity, we will understand how the matter is made up of from small tiny particles. Okay. In activity 1.1, what is given? See, take some 100 ml of water in a beaker and note its level. In a beaker, you can take 100 ml water and note its level. Dissolve some salt or sugar in it with the help of glass rod. You can dissolve some amount of salt or sugar in it with the help of glass rod. The salt dissolves in the water, but the level of water does not change. This is because the particles of water get into the space between the particles of water. When we add the salt in that beaker, the level of water is not increases. Why this is not increases? Because the added salt is enters into the space which is present in that beaker, or that added salt is enters into the spaces which is present in between the water. That's why the level of water is not increases. This shows that the matter is made up of particles. The particles of matter are very tiny. Now how we can understand? We'll see one activity which shows the particles of matter are very tiny. Now in activity 1.2, what is given? See, dissolve 2 to 3 crystals of potassium permanganate in 100 ml of water in a beaker. Now you take 100 ml of water in a beaker, and in first beaker given 100 ml water, and in that you can add 2 to 3 crystals of potassium permanganate. Take 10 ml of this solution and dissolve in 100 ml of water. Repeat this process 5 to 6 times. Means what? Initially we are taking 100 ml water in a beaker. In that we are adding 2 to 3 crystals of potassium permanganate, and we are taking 10 ml of solution from that in a test tube, and again that 10 ml of solution we are adding into next beaker. Repeating this process by adding 100 ml water each time by 5 to 6 times. This shows that a few crystals of potassium permanganate can color a large volume of water, because there are millions of tiny particles in each crystal. By doing this activity, we understand that the particles of matter are very tiny. Property of matter, that is particles of matter have space between them. In activities 1.1 and in activity 1.1 and in activity 1.2, we saw that particles of sugar, salt and potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee or lemonade, particles of one type of matter get into the spaces between the particles of the other. Whenever we are making tea or coffee or lemonade, the particles of one type of matter get into the spaces between particles of the other, and this shows that there is enough space between particles of matter. And by doing this about two activities, we understand that particles of matter have space between them. Now what is given here? You can take two beakers. In first beaker you can add ink from the side of that beaker, and in second beaker you can add honey. Same like that how we added ink in the beaker, and keep them or leave them undisturbed. The ink spreads evenly throughout the water due to the movement of the particles of water and ink. Now why this is happening? Because this ink is intermixes with the water, or the places which is present in between the water. In that spaces this ink enters, and that's why evenly distributed throughout the water. Now see, the intermixing of two or more different types of matter on their own is called diffusion. Diffusion means what? Intermixing of two or more different types of matter on their own is called diffusion. Now we are adding the ink, but automatically they mix with each other, and that this intermixing of two or more different types of matter on their own is known as diffusion. They do so by getting into the spaces between the particles. Yes, they are mixing with each other because of the space is present in between those both the types of matter. That's why they intermix with each other by their own, and this is known as diffusion. Now we'll see next property of matter, that is the particles of matter attract each other. In this activity, what is given we'll see. Activity 1.6, take an iron nail, a piece of chalk and a rubber band. Try breaking them by hammering, cutting or stretching. We are taking one rubber, one chalk and nail. Now what we are doing? We are breaking them by hammering, cutting and stretching. It is more easier to break the chalk, less easier to break the rubber band and difficult to break the iron nail. Now we know that it is very easy to break the chalk than the rubber, and iron nail is difficult to break. This is because the particles in the iron nail are held together with greater force than in the rubber band or a chalk. Now why it is difficult to break the iron nail than the chalk and rubber? Because the particles which are present in the nail are strongly held together as compared to the particles which are present in the chalk and the rubber. And this thing shows that the particles of matter attract each other. In some matter, they are slightly held together, and in some matter, they are closely held together or tightly held together. And it shows that the particles of matter attract each other. Now on the basis of physical property, matter is divided into solid, liquids and gas. Matter exists in three different states due to variation in the characteristics of the particles of matter. Now on the basis of their characteristic, matter is divided into solid, liquid and gas. Now next we'll see what are the properties of solid. First we'll see the solid state. And what are the properties of solids? We'll see one by one. Solids have definite shapes and fixed volume. The meaning of this, if we are taking any substance which is having their shape fixed and their volume is also fixed, it not changes, then we are saying that is a solid. Intermolecular space of particle is minimum. In solid, these particles are very closely held together. The space between two particles is negligible, near about negligible, which is very less. The space which is present between two particles is known as intermolecular space, and in the case of solid, this intermolecular space is very small, near about negligible. In solid state, the intermolecular force between this particle is maximum. Now next property of solid is that movement of the particle is minimum. Intermolecular space of this particle is very less, that's why there is no place to move them, and that's why the movement of this particle in solid state is very less or minimum. They are least compressible, their rate of diffusion is least. They are least compressible means what? If we apply the external pressure on the solid, it easily not changes its shape. It cannot compress, that's why we are saying these are less compressible. Their rate of diffusion is less, means they are not easily mixes with other substances, because intermolecular space is very less, minimum. If intermolecular space is more, then it can easily mixes with other substances. But in the case of solid, what? Intermolecular space is less. That's why there is no place to occupy other substances into that, and that's why the rate of diffusion is very less. The liquid state. Properties of liquid. Liquids have no definite shape but have fixed volume. It takes the shape of the container. The first property of the liquid, that is, liquid have no definite shape but have a fixed volume. The meaning of this is that if we add water in any container, for example, if we are adding water in a beaker, if we are adding water in a glass, if we are adding water in a bottle, that water takes shape of that container. That's why we are saying it have no definite shape but have fixed volume. If we are taking 100 ml water in a glass or beaker or in a bottle, the volume is fixed, it not changes, but the shape changes. That's why we are saying liquid have no definite shape but have a fixed volume. It take the shape of the container, but the liquid take the shape of container because it is not having a definite shape. Space between this liquid is intermediate, means it is not less like the solid and it is not more like the gas. It is medium, and that's why we are saying the intermolecular space of particles is intermediate. Intermolecular force of attraction of particles is intermediate. The force of attraction between this particle is also intermediate. It is not much stronger than the solid and not much weaker than the gas. That's why we are saying the intermolecular force between this particle is also intermediate. They are less compressible. The meaning of this sentence is if we apply the external pressure on the liquid, they compress, but they are less compressible because the intermolecular space is less. That's why they come closer when we apply the external force, but they are not more compressible. The rate of diffusion is more than the solids. Now we know that the intermolecular space between this particle or the intermolecular space of the particles in the liquid is more as compared to the solid. That's why they easily intermix with each other, or they can easily intermix with the other substance, and that's why the rate of diffusion is more in the case of liquids. These all are the properties of liquid. First property of liquid is that liquid is not having definite shape but it is having a fixed volume. The intermolecular space between the liquid is intermediate. Intermolecular force of attraction in the liquid is also an intermediate, and the movement of the particle in the liquid is also intermediate. They are less compressible and their rate of diffusion is more than the solid. These all are the properties of liquids. Third state, that is gaseous state. The properties of gaseous state. Gases have no definite shape or fixed volume. Gases occupy the whole space of the container. Now we learn that in the case of solid, solid is having definite shape, definite volume. Liquid is having no definite shape but definite volume. But in the case of gases, there is no definite shape and not fixed volume. If we take any gas, it is not having definite shape, and if we measure, it is not having a fixed volume. We are not taking 100 ml this gas, 100 ml nitrogen gas, 100 ml oxygen gas, like that. And the particles which are present in the gases, they are very far away from each other. The intermolecular space between this particle is maximum. More space is present in between these particles. That's why we are saying intermolecular space between this particle is maximum. Now next property, that is intermolecular forces of intermolecular force of this particle is minimum because they are very far from each other. They are not near to each other. That's why we are saying the intermolecular force of attraction of this particle is minimum. Movement of the particle is maximum. The intermolecular space is more. That's why they get more place to move from one place to another place. That's why the movement of particle is maximum in the case of gas. They are most compressible. Intermolecular space is more. That's why when we apply the pressure or when we apply the external pressure on them, they come closer, and that's why easily able to compress. That's why we are saying they are most compressible. Their rate of diffusion is more than the solids and liquids. Now we know that the rate of diffusion is also more. Why? Because the intermolecular space is more. That's why they can easily enters into another object, or another substance easily enters into the gas. And that's why the rate of diffusion of gas is very high. Now we'll see one activity, that is 1.11. Take 3 syringes of 100 ml and close nozzle by rubber cork. Remove piston from all them. Leave first syringe untouched. Second with the water, and third with a piece of chalk. Now we are taking 3 syringes here. In first we are not taking anything. In second we are taking water, and in third we are taking pieces of chalk. Insert piston back and try to compress each syringe. Now what we are doing? We are inserting piston on that and we are pressing each syringe. Now what we will observe, see, gases are highly compressible as compared to solids and liquid. Now the syringe in which we are taking gas, or we are not taking anything, that is easily compressible, and the syringe in which we are taking water, it requires little bit force. In which we are taking chalk pieces, it requires more force as compared to the first and second syringe in which we are taking air and second water. That's why we are saying solids are very less compressible as compared to the liquid, and gases are more compressible as compared to the liquid or water. The meaning of this is liquid is more compressible than solid, and the gases are more compressible as compared to the liquids. That's why we are saying gases are more compressible, solids are less compressible, and liquids are intermediate compressible. An example, that is compressed gas. Due to its high compressibility, large volume of a gas can be compressed into a small cylinder and transported easily. Because of this compressibility property, gas can be compressed, or large amount of gas can be compressed in a small cylinder, and which we can use as a fuel. The liquefied petroleum gas, that is LPG, cylinder that we get in our home for cooking, or oxygen applied to hospitals in the cylinder, is compressed gas. Compressed natural gas, that is CNG, is used as a fuel these days in a vehicle. Now we are saying LPG. What is that LPG? LPG is a liquefied petroleum gas. The meaning of this sentence is that this is a gas, but by applying external force, we are compressing that gas, and because of intermolecular space is reduced, that's why that gas turns into liquid, and this is known as liquefied petroleum gas. We applied external pressure on the gas, and that's why it turns into liquid. That's why we are saying liquefied petroleum gas. Same like this, we are using this CNG and other gases in the form of liquid by applying external pressure, which are known as compressed gases. How the smell of food reaches our nostrils without even entering into kitchen? Now this is very familiar example for us, that when we are coming from outside in the house, that time we are easily able to understand what cooked in our home. How it is possible? Because of smell only. Now how does the smell of food reaches our nostril without even entering into kitchen? The particles of the aroma of food mixed with the particles of air spread from the kitchen reach us and even farther away. The smell of hot cooked food reaches us in seconds. This is because of high speed of particles and large space between them. Gases show the property of diffusing very fast into other gases. Now we learn that what is meant by diffusion. The intermixing of substances into each other is known as diffusion. In the case of gases, intermolecular space is very high. That's why they can easily mixes into another substance, and that's why only the smell of that cooked food easily mixes into the air, and through that air we get the smell of food easily without enters into the kitchen. And this is happens only because of the process of diffusion. Motion of gaseous particles. In the gaseous state, the particles move about randomly at high speed. Now we learn about the different properties of solids, liquids and gases. In case of gases, intermolecular space is very high as compared to the liquids and solids. That's why the particles get more space to move, and they are moving very randomly. They are not moving in definite direction. They are moving in all the directions. That's why we are saying the speed of the particle which are present in the liquid are very high. Due to this random movement, the particles hit each other and also the walls of the container. Because of the movement of this particle, they hit the wall of the container. The pressure exerted by the gas is because of this force exerted by the gas particles per unit area on the wall of the container. Now see, the particle of the gases hit to the container of the wall and which produces or which exert the force on the container, and which is known as pressure. Pressure is what? Force per unit area. Whatever force applied by these particles on the container on that area, that is nothing but the pressure. That's why we are saying that the pressure exerted by the gas is because of the force exerted by that area by these gaseous particles. We learned that there are three states of matter: solid, liquid and gases. Another states are also there, but that is not in your syllabus, that is plasma and BS. Change of state, that is change of substances from one physical state to another, is called change of state. It occurs during heating or cooling of substances. There are total three states of matter: solid, liquid and gas. These all three states are interchanges into each other by changing their temperature and pressure. How they interchange? And the change of substance from one physical state to another is called change of state. Now we'll change of state. Change of substance from one physical state to another is called change of state. It occurs during heating or cooling of substance. Now see, there are three states of matter: solid, liquid and gas. These all three states are interconvertible by changing their temperature and pressure. And this change of substance from one state to another state is known as what? Change of state. Solids can be converted into liquid, liquid can be converted into gas, again gas can be able to convert into liquid, and again liquid can be able to convert into solid. And this change of substance from one physical state to another physical state is known as change of state. Now the effect of change in temperature. Now what is the effect of change in temperature? Take a 150 gram of ice in a beaker and suspend a laboratory thermometer so that its bulb is in contact with ice. We are taking 150 gram of ice in a beaker and keeping thermometer and start to giving heat to that beaker by using this flame, and note the temperature. What we'll observe, we are giving heat to that beaker, but still the temperature of ice is not increases. Why? Because whatever temperature we are giving, that temperature is used to change the state of that substance. Substance means what? Ice. Whatever ice we are taken in this beaker, that turns into water, and that given temperature is used to change the state from ice to water. That's why the temperature of ice is not increases. Is the observation from this activity? On increasing the temperature of solid, the kinetic energy of the particles increases. Due to the increasing kinetic energy, the particles start vibrating with greater speed, and thus particles gain enough strength to break intermolecular force of attraction. The particles start moving more freely from their fixed position, and stage is reached when the solid melts and is converted to a liquid. Now what we learned from this activity, when we are giving heat to the solid, intermolecular activity, that on increasing the temperature of solid, the kinetic energy of the particle increases. Due to the increasing kinetic energy, the particles start vibrating. Kinetic energy of particle increases, that's why the particles start to vibrate and they easily able to break. Observation: on increasing the temperature of solids, the kinetic energy of the particles increases. Due to the increase in kinetic energy, the particles start vibrating with greater speed. Now see, because of giving temperature, the kinetic energy of the particles increases, and due to the increase in kinetic energy, particles starts vibrating with greater speed. And thus particles gains enough strength to break intermolecular force of attraction. The particles start moving more freely from their fixed position. A stage is reached when the solid melts and converted in a liquid. From this activity we learn that by giving heat to the solid, it can be turned into the liquid. See, what is meant by melting or fusion? What is meant by boiling point and latent heat of fusion, latent heat of vaporization? These different terms we are going to see in this class. Now, when we are giving heat to any substance or any solid substance, that time what happens? That solid get turns into liquid, and the temperature at which that solid get turns into liquid at its atmospheric pressure is known as its melting point, or we are saying fusion. The exact point or exact temperature at which solid get turns into liquid at its atmospheric temperature is known as its melting point, and that process is known as fusion. For example, see, if we are taking ice in a beaker and we are giving heat to this ice, then it absorbs some amount of heat and it turns into water, or it melts into water, and that temperature is known as its melting point. Melting point: the minimum temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. Just we learn about what is meant by melting point. Now we'll see the melting point of ice is 273.15 Kelvin, or we are saying 0 degrees Celsius. There are two units of temperature. Generally we are using degree Celsius, sometimes we are using Kelvin, but here given the melting point in both Kelvin as well as in degree Celsius. Now what is a melting point? Melting point of ice is 273.15 K, or we are saying 0 degree Celsius. This is all about the melting. When a solid melts, its temperature remains the same. So where does the heat energy go? When we are giving heat to the solid, the temperature of that solid is not increases but is turns into liquid. Then where it extra temperature goes, we'll see. During the experiment of melting, that the temperature of the system does not change after the melting point is reached till all the ice melt. Till melting point temperature will rise, After that, it will not raise. Why this is happening? Even though we continue to supply the heat, this heat energy is absorbed by ice without showing rise in temperature. This heat gets used up in breaking the force of attraction between particles. Now whatever extra amount of heat we are giving, that heat is used to break down force of attraction between those particles, and that's why it turns into one state to another. Means whatever extra amount of heat we are giving more than the melting point, that heat is used to break down the force of attraction between the particles, and that's why the temperature of that solid is not raised after its melting point. It is considered that it gets hidden into the contents of the beaker and is known as the latent heat. Latent means hidden. What is meant by latent heat of fusion? Latent heat of fusion. Now we'll see the meaning of latent heat of fusion. The amount of heat energy that is required to change 1 kg of solid into liquid at atmospheric pressure at its melting point is known as the latent heat of fusion. Now if we are taking 1 kg of solid and it turns into liquid at its atmospheric pressure and it at its melting point, then it is known as latent heat of fusion. Means whatever amount of heat energy is required for 1 kg of solid turns into liquid, that heat energy is known as its latent heat of fusion. So particles in water at 0 degree Celsius, that is equal to 273 Kelvin, have more energy as compared to particles in ice at the same temperature. Now what is the relation between degree Celsius and Kelvin? 0 degree Celsius is always equal to 273 Kelvin. Particles which are present in water have more energy as compared to the particles which are present in the ice. Now see here, this is because of the change in state. In water, the particles are loosely bound, and in ice, particles are closely held together. That's why. Kelvin scale. Kelvin is the SI unit of temperature. For measuring the temperature, we are using degree Celsius, Kelvin, but Kelvin is the SI unit of temperature. 0 degree Celsius is equal to the 273.15 Kelvin. For our convenience, we take 0 degree Celsius is equal to 273 Kelvin after rounding of the decimal. Actually, it is 273.15 K, but for our convenience, we are using that 0 degree Celsius is equal to 273 Kelvin. To change a temperature on the Kelvin scale to the Celsius scale, you have to subtract 273 from the given temperature. To change the temperature on the Kelvin scale to the Celsius scale, we need to subtract 273 from the given temperature. For example, see, if we want to convert Kelvin temperature into Celsius temperature, if 100 Celsius or 100 degree Celsius temperature is given, now how much is the Kelvin temperature? We need to minus 273 from that 100 degree Celsius, and whatever answer we'll get, that is equal to Kelvin scale. Means 100 minus 273 will get minus 173, and that is Kelvin scale. How to convert a temperature on the Celsius scale to the Kelvin scale? You have to add 273 to the given temperature. Now if we want to convert temperature into degree Celsius to the Kelvin, then what we are doing? We are adding 273 into Celsius temperature, will get the temperature in Kelvin scale. For example, 1 degree Celsius is the temperature of any substance. We want to convert it into Kelvin, then what we are doing? We are adding 273 into that. 1 plus 273 is equal to 274 Kelvin will get. Means if we want to convert temperature into Kelvin to Celsius, then what we are doing? We are subtract 273 from that, and if we want to convert it from Celsius scale to Kelvin, then what we are doing? We are adding 273 into Celsius, then we'll get that temperature into Kelvin scale. Next point, that is boiling point. In day-to-day life, we are using boiling point. So what is mean by boiling point? Now supply heat, energy to water, particles start moving even faster. At a certain temperature, a point is reached when the particles have enough energy to break the forces of attraction. At this temperature, the liquid starts changing into gas. Now we know that when we start to give the heat to the water, immediately it cannot be turned into vapor. It will require some time to convert into vapor. When we start to give the heat to that liquid, it absorbs that energy, and at exact temperature at which it starts to turn into vapor, that temperature is known as what? Boiling. The exact temperature at which liquid turns into its vapor is known as its boiling point. Now we'll see the definition of boiling point. The temperature at which a liquid starts to boiling at the atmospheric pressure is known as its boiling point. Boiling is a bulk phenomenon. Particles from the bulk of the liquid gain enough energy to change into the vapor state. For water, this temperature is 373 Kelvin, which is equal to the 100 degree Celsius. Now we know that the boiling point of water is 100 degrees Celsius. If we want to measure it in a Kelvin, we need to add into that 273 and it will get a 373 Kelvin. This is effect of temperature on molecular motion. If any substance is in a solid state and we are giving heat to that, when it absorbs heat, the particles of solid go far away from each other, and in those particles intermolecular space will increase. Now when we are giving heat to the liquid, they are also going far away from each other and intermolecular space between them also increases. This is the effect of temperature on molecular motion. The movement of particles in both solid as well as in a liquid, when we are giving heat to them, it increases, or the kinetic energy of those particles when we are giving to heat them, it automatically start to increase. Activity 1.13. Take some camphor or ammonium chloride, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug on the stem of the funnel. Now heat slowly and observe. Now what we need to do in this activity, that we are taking one camphor or ammonium chloride and we are crushing it and keeping in a china dish. After that, what we are doing, we are keeping one inverted funnel on that and close that end of the funnel with the help of cotton plug. After that, slowly we are giving heat from downside and we'll see what are the observations. Now see observation. If solid camphor or ammonium chloride is heated, it changes into vapor. If the vapors are cooled, it changes into solid. After doing this activity, we understand that when we are giving heat to that camphor or ammonium chloride, it is turns into vapor, and if we reduce the heat, then it again turns into solid. But generally the substances or the solid substances, when we are giving heat to them, that turns into liquid and then it turns into vapor. But in the case of this camphor, what happens? It directly turns into solid to vapor. That is the main difference here. And the substances, the process in which solid directly turns into gas without changing into liquid phase is known as its sublimation. Once again, we'll see what is meant by sublimation. Direct change of solid to gas without changing into liquid state is known as sublimation. And camphor and ammonium chloride, these are the good examples of substances which undergo sublimation. Next, we'll see what is meant by deposition. direct change of gas to solid without changing into liquid is called deposition. This is exactly the reverse process of that sublimation. In sublimation, solid directly turns into vapor, and in deposition what happens? Gas is directly turned into solid without changing into liquid. That's why the definition of deposition is direct change of gas to solid without changing into liquid is called a deposition. We learned three states of matter: solid, liquid and gas. Is that possible to turn those each phase into one another? Of course it is possible. How? By changing its temperature and pressure. We'll see how they convert from one state to another state. And the change of state of matter by changing its temperature and pressure is known as interconversion of three states of matter. By changing temperature and pressure, we are able to change the state of matter. And what are the different terms we are using for those change? We'll see one by one. When we turn solid into liquid by giving temperature, that process is known as fusion. And when liquid turns into gas, that process is known as vaporization. The process in which gas turns into solid is known as deposition. And when solid turns into gas, that is a sublimation. Now we'll see reverse. When gas turns into liquid is known as condensation. And liquid turns into solid, that is known as solidification. Now we'll see one example of this. Example of fusion: when solid turns into liquid, that is the best example of ice. When ice turns into water, that is the example of fusion. Again, when water turns into vapor, that is vaporization. Sometimes what we are doing, vapor, because of temperature, it turns into liquid, and that is known as condensation. Water, again, when we reduce the temperature, it gets converted into ice, that is known as a solidification. And the last example, that is of sublimation. Just we learn about that. Camphor and ammonium chloride are the best example of sublimation, which is solid turns into gas. And deposition, which is exactly reverse to that of this sublimation, gas directly turns into solid without changing into liquid state. This change in state of matter is known as interconversion of three states of matter. What will be the effect of change in pressure on matter? We'll see. When pressure is applied on gas, particles come closer and the gas changes into liquid. For example, if you consider this is a gas and whose particles are very far away from each other. When we increase the pressure on those particles, what happens? Those particles come closer, and that's why it changes into liquid. Because in liquid, intermolecular space is less. That's why when we apply more pressure on the gaseous state, it can be easily converted or turns into liquid. Now next we'll see, we can liquefy gases by applying pressure and reducing the temperature. See in this diagram, when we are taking gas in a cylinder and with the help of piston we apply external pressure. Because of external pressure, what happens? Those molecules come closer and it turns into liquid. If we again apply pressure on that, these particles again come closer and it again turns into solid. Means what happens? Because of applying pressure, intermolecular space between those molecules decreases, and that's why the change of state takes place. Now compressed solid carbon dioxide is called dry ice. We know that CO2 is available in the form of gas, but if we applying pressure on that by compressing that CO2, it is able to turn into solid state, and that solid CO2 is known as dry ice. If the pressure is reduced, it changes directly to gas without coming into liquid state. Interconversion of the three states of matter, we just learn about that the states of matter are interconvertible. The states of matter can be changed by changing the temperature or pressure. Next, the important process, that is evaporation, we'll see. The change of liquid into vapor at any temperature below its boiling point is called evaporation. Now we know that at its boiling point, every liquid turns into its vapor state. But below boiling point, if any liquid turns into its vapor, then that process is known as evaporation. Evaporation is a surface phenomenon. Particles from the surface gain enough energy to break the forces of attraction and changes to vapor state. Now we are saying evaporation is a surface phenomenon. Why? If we are taking 100 ml of water in a glass and we are taking 100 ml of water in a plate, and we are keeping those both the utensils under the sunlight, and observe which water or the water in which utensil evaporate earlier. Of course, the amount of water is similar in both glass as well as in plate, but the water which is present in the plate is evaporate earlier than the water which is present in the glass. Why this is happening? Because the surface area of plate is more and the surface area of glass is less. That's why we are saying evaporation is a surface phenomenon. Means if the surface is more, evaporation is more. If surface is less, evaporation is less. That's why evaporation is totally depends on its surface area, and that's why we are saying evaporation is a surface phenomenon. There are some factors which affecting to the evaporation. Which are those factors? We'll see. Factors affecting evaporation. Activity 1.14. Take 5 ml of water in test tube and keep it near a window or under a fan. What we are doing here, we are taking 5 ml of water in a test tube and keep it near a window or under a fan. By taking that 5 ml water in a test tube, we are keeping it under fan or near the window. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Now what we are doing, we are taking that same amount of water in a china dish whose surface is bigger as compared to the test tube, and we are keeping that same under the fan. Take 5 ml of water in an open china dish and keep it inside a cupboard or on a shelf in your class. Repeat that about 3 steps of activity on rainy days. Now what we are able to observe, see, the rate of evaporation depends upon the surface area, temperature, humidity and wind speed. Rate of evaporation depends on all the things: surface area, temperature, humidity and wind. All these factors affect the rate of evaporation. How these factors affect the rate of evaporation, we'll see one by one. Increase in the surface area increases the rate of evaporation. Means if surface area is more, rate of evaporation is also more. Increase in temperature increases the rate of evaporation. If the temperature of the atmosphere is more, rate of evaporation is also more. We'll see one example of that. In summer, temperature is high. That's why easily our clothes get dry. But in rainy season or in winter, the temperature is less. That's why it will take more time to dry our clothes. That's why this example is good to show that increase in temperature increases the rate of evaporation. Increase in humidity decreases the rate of evaporation. In rainy season, what happens? The temperature is humid. What is meant by humidity? The amount of water present in the atmosphere is more. That is known as humidity. And if humidity is more, the rate of evaporation is automatically less. And the increase in humidity decreases the rate of evaporation. Increase in wind speed increases the rate of evaporation. For example, if wind rate is more in the atmosphere, evaporation is also more. In detail, we'll see how the increase in the surface area increases the rate of evaporation. Evaporation is a surface phenomenon. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying, up we spread them out. That's why surface area increases and it will take less time to dry our clothes. Increase in temperature increases the rate of evaporation. With increase of temperature, more number of particles get enough kinetic energy to go into vapor state. Next, increase in humidity decreases the rate of evaporation. What is meant by humidity? Humidity is the amount of water vapor present in air. Humidity in rainy season and winter season is more as compared to the summer season. The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. We know that in summer rate of evaporation is more and in rainy season evaporation is less because of that humidity which is present in the atmosphere. Increase in wind speed increases the rate of evaporation. It is a common observation that clothes dry faster on a wind day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Now in this picture also shown that if the wind is more, then the evaporation takes place fast, and that's why our clothes get dried in less time. Sometimes if we want to dry our clothes in less time, that time what we are doing, we are keeping those clothes under the fan so that wind will get, and because of that wind evaporation takes place faster and our clothes get dry in less time. How evaporation causes cooling, we'll see. When a liquid evaporates, the particle of the liquid absorb heat from the surrounding and evaporate, so the surroundings become cool. Examples: pour some acetone, that is nail polish remover, on your palm. Observation: the particles gain energy from your palm or surrounding and evaporate, causing the palm to feel cool. During summer we sweat more. We know that during summer we sweat more, and what happens, because during evaporation the sweat absorbs heat from our body, making the body cool. Our skin sweating more, and for evaporation that sweat takes heat from our skin, and that's why our skin feel cool. Wearing cotton clothes in summer keeps us cool. In summer season we are wearing cotton clothes. We are not wearing any winter clothes. Why? Because cotton absorbs sweat, and when the sweat evaporates, it absorbs heat from our body, making the body cool. See, sweat glands secrete sweat from our skin, and when it starts to evaporate, for evaporation that take heat from our body, and that's why our skin feel cool in the summer season. Sometimes what happen, we are keeping some ice in a glass, and outer surface of that glass keeping dry. Still, after some times we observe some droplets on the outer surface of the glass. Why this is happening? We see water droplets on the outer surface of glass containing ice cold water. The water vapor present in air on coming in contact with a cold glass of water loses energy and gets converted to liquid state, which we see as a water droplets. Now we know that the outer surface of glass is dried. Still, after some time, whatever water vapors are present surrounding to this glass, because of less temperature near this glass, what happens, those water vapors turns into liquid, and those droplets are deposited on the outer surface of the glass, and the conversion of this water vapor into liquid is known as condensation. This way our chapter is finished. In this chapter we learned so many things, from matter to this